One of the more popular tools that people use for automation with NSX is Terraform. It's declarative, it's cloud agnostic, it's Go-based, and it allows you to be able to have a planning phase where you can look at the changes that are proposed that it's going to make against the NSX Manager, and then you can finally apply them to the NSX Manager, making configuration changes. Terraform has a provider that is used to be able to interact with NSX. You use a configuration file to define exactly what objects you want to have created, which then interacts with the Golang SDK, which is auto-generated by Swagger CodeGen, which interacts with the NSX Manager to make configuration changes. One of the use cases would be logical topology automation, where you create a workflow that has CRUD actions to be able to create logical switches and logical routers with layer 2, layer 3, and north-south connectivity, ECMP topology creation, DHCP server creation. You can configure NAT, create edges and distributed firewall rules, load balancing policy, federation, and much, much more. Some of the preconditions are you need to have hypervisor host deployed, you need to have your vCenter deployed, you need to have your physical networking configured for uplinks and TEP networks, some physical networking configured for BGP peering, and a client machine with Terraform. So let's look at some of the Terraform concepts. We have a provider which is responsible for the lifecycle of a resource. These are CRUD actions like create, read, update, and delete. And most providers require some sort of configuration to provide authentication information, endpoint URLs, etc. So in this case, we have the FQDN of the NSX Manager, the username, the password, and allowing unverified SSL. A data source is data sources allow data to be fetched or computed for use elsewhere in Terraform configuration. And then finally, we have resources, which are a component of your infrastructure, which lifecycle you want to manage. So this is the actual object. In this case, we're creating a policy group of all VMs, and we're setting conditions dynamic matching criteria, which is a virtual machine that contains a tag with a value of my tag. This is showing a list of supported resources and data sources. In data sources, you can see that we have transport zone, switching profiles, policy tier 0, tier 1 gateways, services, and many, many more. Resources, we're talking about logical switches, we're talking about groups, we're talking about router links, ALG types, and IP protocol. So many, many different types. All of them are documented under terraform.io. You can go under the provider and you can look up the NSXT provider, which has all the documentation listed to see all the different devices, data sources, and resources that you can create. Let's take a look at some of the day one operations that can be done with Terraform. So we can create a tier 0 gateway, create a tier 1 gateway, we create segments, create groups, and create security policies, all within one manifest. We have Terraform do a plan, and then finally an apply, and then once that's all created, all of these components are going to be created within the NSX Manager all in one go. All the day one configuration options and many more are all documented within the Terraform provider. Please go to the website and you can find updated information on all the different resources that can be created. Some of the benefits and limitations of using Terraform. So some of the benefits are the ability for you to be able to do Terraform plan so you can see what changes are going to be made in your environment before actually applying them. You can leverage other providers, for example, the vSphere provider for compute. You have a single file to provision compute and networking, so everything has a main source of truth. Some of the limitations are not all features are exposed, but this is changing on a daily basis. New features are being included and active development happens with Terraform. So you can usually bet that changes are going to eventually be seen within the Terraform provider as time moves on. Terraform examples are available at our GitHub at VMware Samples, NSXT, Tree Master Terraform, and it has plenty of examples for you to be able to at least get an understanding of how to be able to build out a configuration file and then make changes to your NSX Manager using Terraform. Ansible is another popular option that customers use for automation. Typically, this means that users are going to create some type of Ansible playbook. It will then be submitted to the Ansible automation engine, which will then create the different types of objects within the NSX Manager. This is used for day one operations. This could be as simple as creating NSX edges and transport zones, all the way up to creating policy and groups. Let's go over some of the Ansible concepts. You have an inventory. This provides information about hosts or nodes that Ansible can connect. Data from various sources can be managed by Ansible through variables. Tasks are the application of a module to perform a specific unit of work. And then you have the plays and the playbooks, which are an ordered set of tasks to execute against host selections from your inventory. For an automated installation, there are a few preconditions. You must have vCenter and hypervisor hosts deployed. You must have your physical networking configured for uplinks and TEP networks. You must have a client machine with Ansible. It needs IP connectivity to the NSX Manager and vCenter server. And you need Python version 3.x. You need Ansible and OVF tool installed. Let's go over the install workflow. So first you would deploy the first NSX node. You would configure a compute manager. You would then deploy a second and third NSX node. Then create transport zones and transport node profiles. Prepare transport nodes, the host and the edge. And then finally create an edge cluster. In step 1, we deploy the first NSX node. This is usually with OVF tool. You can use an OVA or OVF via local or remote, HTTP and FTP. And you can use a user-friendly vSphere inventory names for data centers, clusters, data stores, and networks. You then wait for the manager to be up. You can get this status by using an API call to get the cluster manager status, and then you can parse output to check if all services have status of up. In step 2, we configure the compute manager. We can get the compute manager information to check if it already exists. We can get the vSphere thumbprint, and then we can post up the configuration that we want via API v1 Fabric compute managers. In step 3, we deploy the second and third NSX nodes. We need to get the vSphere MOBID for the data center, the cluster, the data store, and the port group. We can then get the deployment information to check if the node already exists. And then we could check the compute manager to parse and get the vCenter ID. And then we post up our deployment changes that we want to make. In step 4, now that we have the NSX management cluster created, we can now create transport zones. We can check if they already exist and then post the changes. We can configure our TEP IP pool. This is optional. This is for if you're going to use overlay networking. But most likely, if you want to use it, you're going to have to create this. So it doesn't hurt if you create it just to prepare for it anyway in the future. And you would do that with a post call. Then you can create a host switch profile. This is also optional. This is for overlay networking, but can't hurt to be able to create it. You do that with a post call. And then you can configure your transport node profile. You first parse and get the information about the host switch profile IDs. And then you get the transport zone IDs, and then you post up the transport node profiles that you want to create. In step 5, we prepare the transport nodes, the hosts and the edges. First get the information, and then like everything else, once you gather all the information that you want, you can then post the transport node configuration that you wish to deploy. And then in step 6, we finally create the edge cluster, which then we'll associate the edges to, and we get the information about the edge transport node IDs, and we include those into creating the edge cluster so that they are associated with it. You can see this example in our playbooks and our variables. We have a YAML file, we have a GitHub that's posted, the link is above, and you can check out exactly how this is done and do it in your own lab. We also have examples of a day 0 configuration, which has all the information that we had in previous examples. Feel free to look at the playbooks and the variables in the Ansible GitHub that we have, just like in the previous example that we showed. So much like the Terraform workflow for day 1 operations, we can do the same thing with Ansible. We have the ability to create a tier 0 gateway, a tier 1 gateway. We can create segments, groups, and then finally security policy and rules. This example is also provided in the same GitHub, Ansible for NSX, and you can see the full playbooks and variables for each of the components. Some of the benefits and limitations of Ansible: we have the ability to leverage NSX and vSphere providers and playbooks. We can work with multiple sources of truth, and we have a single file to provision compute and networking. Not all features are exposed in NSX Ansible modules. Much like Terraform, we try to make sure that we keep up with them as much as possible. And also, much like Terraform, you need an account with access to the NSX environment in order to be able to authenticate and then make changes. NSX automation can also be performed with Power CLI. So let's go over some of the concepts. We have a module, which is basically a grouping of various functions that operate as a single mini program. So you install the module and then you get access into these commandlets. And a commandlet is a lightweight command that is used to perform a specific operation like list, create, delete, patch. And then, of course, you create the PowerShell script, which is a .ps1 file, which is a collection of the commandlets and variables to execute a deployment or request with different objects. So you need to install Power CLI for NSX, which you install PowerShell. For Windows, it is already installed. For Linux, it would be a simple apt-get if you're talking about Ubuntu or such. And then Mac, you can use Brew. And then you can install Power CLI using the install module command, and then you specify the name being VMware Power CLI, and then finally the SDK NSX policy. There are various useful commands that you can use. Obviously, there are things like git commands where you can specify the module, and you can get things like a tier 0, or you can list the tier zeros. You can do operations specified based on the path, which is very much the same as if you were doing a raw REST call. In this example, we have something for getting the infra tier zeros or the segments. You can also invoke the help to be able to get a full understanding of what the commands can do. And you can also do operations where objects, and you can define things like the name, update infra segment discovery, so you can find the commandlets that you need to be able to execute whatever task you're trying to accomplish in the script. For the Power CLI authentication, you first have to connect to the NSX server. You define the IP address or fully qualified domain, obviously the user and the password, and you have to make sure that you ignore an invalid certificate if you have an SSL generated certificate that is untrusted. And then you can set the Power CLI configuration. You can set the scope. You can set the invalid certificate action to ignore. And once you have all that, and also the participate in the CEIP, you can set those values as well. And then once you're authenticated, you can now execute commandlets to actually do CRUD actions against the NSX manager. You can filter on properties. So for example, we have a segments variable that invokes and lists all the infra segments. And then we can look at the options and we can do parsing of a where object and looking for an admin state of up. We can get help so that we can get a listing of exactly where these functionalities are and then how to be able to utilize them. Here's an example of us being able to create a tier 0 router. First, we can get help and we can look for the invoke, create, or replace tier 0. And we look for examples. And then finally, in this case, we're going to create a tier 0 in a variable by initializing tier 0. And then we can explore the tier 0 by doing a create or replace the tier 0, and then do explore, and then tier 0 set as the initialized tier 0 that we did as the variable of tier 0. Some of the benefits and limitations, the ability to leverage NSX and vSphere providers in a single PowerShell script. They're auto-generated with NSX, so all features are exposed. And a single file to provision, compute, and networking. So you can see the benefits of all three. They have the ability of being able to provision multiple types of objects across many different things like compute and networking and security, all within a single file. These are low-level commandlets, though, so that's one thing to be to understand is that these are very powerful, and they do require some knowledge of how to navigate the object schema. VMware Cloud Automation, or VCF Automation, has many different components for you to be able to automate your full private cloud. You have the things like Service Broker, CodeStream, and Cloud Assembly, but all of these interact with the policy-based API that we have for NSX to be able to create networking and vDefend security objects. So NSX with ARIA Automation, or VCF Automation, you're able to create segments, gateways, distributed security policy, and security tags, and much, much more. You would create within your service catalog the ability to do resource reservation. This could be part of your cloud management platform. You can create a multi-machine blueprint and have all of these things interact to be able to create not only your virtual machines or your workloads for your application, but then create the virtual networks, i.e. the segments, the gateways, and then attach security policies, i.e. gateway policy or gateway firewall and distributed firewall policy, so you can create everything all on demand for each of your applications and your developers for dynamic environments. This is showing an example of the rich capabilities for administrators and a simplified consumption for end users. So the administrator can go through and in Cloud Assembly create a blueprint, which will have a template of a load balancer. It could be VMs or workflows. You can create segments and tier 0, tier 1 routers. And then the consumer on the other side can consume this network profile and this blueprint. They can fill in all the information for each of their VMs to be created and their security policy. And then it's all deployed all at once using our declarative model. And they don't have to worry about creating complex automation for it. They can just consume whatever the administrator gives them. You can use existing security groups, or you can create your own security groups on demand. Those are both possible. You can do updates to them. So, the flexibility is within the platform. You're able to build up security profiles and being able to build up reusable blueprints that then makes a simplified experience for the end users. This is showing an example of the Cloud Assembly network options for NSX. You can see that it's a simplified YAML payload that you can utilize. And then, for example, networks in Cloud Assembly are defined by a network type, public being an uplink to internet, private being a private network or SG isolated, outbound, which is NATed, and existing, which is deployed and discovered or routed with NSX. So network types are cloud agnostic except for routed, which is NSX dependent. And routed network type is specific to NSX for creating on-demand routed networks with NSX route advertisements. This is showing the Cloud Assembly pre-created networks and how it links up to NSX and the NSX constructs. So you can see private, which creates a logical switch and some groups. Outbound, which creates a logical switch, a DHCP server, a tier 1, and a one-to-many NAT. And then routed, we can see that we're creating a logical switch, DHCP server, tier 1, and advertise NSX routes from the new networks that are generated behind the tier 1, or it could even be connected to the tier 0. But in this case, we can see that the tier 1 has these cloud generated networks, and that will be shared up to the tier 0, and in turn through potentially BGP over to the rest of the network, the enterprise network, so that it can reach it from a networking standpoint. Here we're showing an example of creating and using tags. So we can create some vSphere tags, we can create VM NIC tags as well, and we can create NSX logical switch and segment tags. So we have flexibility to be able to create tags at every single aspect of your private cloud deployment. Some of the benefits and limitations. So with a VCF automation, we have the ability to implement control and tenancy on top of NSX. We can do a single blueprint which provisions compute. We have the ability to have this blueprint for cloud agnostic constructs and single file to provision compute and networking. There are additional components to manage, obviously with vRealize automation or VCF automation as it's known, but that can be solved with a little bit of work and operations. And then abstraction of VRA or ARIA automation brings value but hides some of the NSX knobs. So you have to work with your blueprints and your end users, your customers, to be able to understand exactly what their automation needs are, and then you can you can expose these things by writing them into your blueprints or make them available in a service broker catalog of some sort. So when it comes to picking the right tool, it really depends on what your requirements are. You have to look at if it's install, upgrade, policy, or features. Look at all those things, and then that will help you determine which tool you want to use to be able to meet your automation needs. You can use the browser web developer tools to be able to help you with your automation strategy. If you're uncomfortable reading NSX API documentation and you want to try to figure out what the UI would do when making those exact same calls, you bring up the Web Developer Console and you can see a plethora of information about what calls are being made and what the payload is. So this is a good way to be able to understand how to be able to build your automation calls by using the UI first. Once you bring up the browser Web Developer Tools, you can see the URI that's used for the call. You can see the method, in this case put, and the payload that's involved and the status, everything that's returned. So it makes it easy for you to then be able to copy this over and do this in Postman or any other language, or build up using ARIA automation or VCF automation to be able to make the exact same calls. Once the call comes back in this example, we can see all the information that was used for the request, and then we can mimic that in our own automation scripts. If we need to get the path from the NSX UI, you can simply go over to the group and hit the copy path to clipboard, and then you'll have a copy of the actual path to the resource, which will make it easier for you to then be able to use in your own URL and URI composition for your automation scripts. And here's an example of using Postman, using the information that we already got from the developer tools, and we're just bringing it over and using the exact same functionality. So in our GitHub VMware samples, we have a 3-tier app that's deployed that uses all the different methods. So you can see the hierarchical API, you can see the Terraform provider, you can see VRA Cloud Assembly or VCF automation, Ansible modules, or the NSXT Power CLI. All the resources are listed here for you to be able to utilize. Be sure to check them out and get the latest information from each one of them, and we keep on evolving this information as we move on. So all this is good information for you to be able to learn more about automation. Thank you for listening to this training video.